Thank you for joining this lesson. We're going to discuss floating and sinking. Number 18, part A. State the Archimedes principle. We should know that the statement of laws is very sensitive and should be as the law is. You don't have to paraphrase a law. You don't have to shorten a law. You don't have to lengthen the statement of laws and principles. So for Archimedes' principle, it should be noted that it states that when a body is fully or partially immersed, when a body is fully or wholly or partly immersed in a fluid, let me underline fluid, I'll tell you why. It experiences an upthrust equal to the weight of the fluid displaced. So most of the learners will make mistakes. More so on the statement of this law, they will say that when a body is wholly or partly immersed, instead of immersed, we can say submerged in a fluid. So they will make a mistake of saying water in this case. Anyway, water is a common fluid or liquid. They'll make mistakes of either saying water or a liquid. So that will attract a wrong in your answer. So when you are stating Archimedes' principle and also the law of flotation, you should never say water. You should never say liquid. This one will attract a wrong. So never say water, neither liquid. It should be strictly a fluid. In the second question, we've been told that the figure below shows a block of mass 50 grams submerged in a certain liquid of density 800 kilograms per meter cubed and suspended from uniform horizontal beam by masses of a string. A mass of 40 grams suspended from the other end of the beam puts the system in equilibrium. Therefore, we got the system made to be in equilibrium by suspending a mass of 40 grams on this end, while on the other end, a mass of 50 has been submerged in a liquid of density 800 kilograms per meter cubed. Now, the first case, we've been told to determine the upthrust acting on the block. The first thing we should do here, on the system, the 40 grams mass is just as it is. It's the real weight which is suspended in air. Therefore, the weight acting here is the weight due to this mass, and this weight can be determined. So the force here, which you can call force 2, can be determined by, when we take the mass, we make it SI unit by dividing by 1000, then we multiply by G, because weight is usually mg. So mass, we make it SI units times G, which is 10, and this becomes 0.4 Newton. So we got a 0.4 Newton at this end, but the force acting here is unknown. So we can determine force 1. We will apply the principle of moment. The principle of moments, or the law of lever, which states that for a system in equilibrium, the summation of clockwise moments is equal to the sum of anti-clockwise moments about the same point. Therefore, now applying that principle, we will say that a sum of clockwise moments is equivalent to the sum of anti-clockwise moments. So now our question will be, which forces are contributing to the clockwise moments, which forces are contributing to the anti-clockwise moments in this case. So we will have, remember this distance is 20 centimeters. We can make it SI units by dividing it by 100. So we will have 0.2. Moments should be force times distance. So a force of 0.2 meters times a force, this is a distance of 0.4 times a force of this. This will give us the clockwise moments. It's only one force. Should give us the unknown force here, which we're calling now force 1, times the distance from the turning point. So the distance is 0.32. Now that it is in centimeters, we make it SI units. Therefore, the value of F1, is going to be 0.2 by 0.4. Then we divide by 0.32. This gives us 0.25 newtons. 0.25 newtons. Now there's something we're supposed to know, that 0.25 newtons is the force which is acting here. But now, what is the real weight of this block? What is the real weight of this block? Now, real weight is going to be the first weight there, mg, whereby we will take 50 over 1,000 times 10. This becomes 0.5 newtons. So the real weight of the 50 gram mass is 0.5 newtons. But now we can see the force it is exerting is 0.25. That means we have the real weight and we have the apparent weight. For us to get upthrust, we need the real weight minus the apparent weight. The real weight minus the apparent weight. That means the real weight of 0.5 minus the apparent weight, because we are seeing at the end of the day this force exerts only 0.25. Then it means there is an upward force of 0.25 newtons, which is acting on the block, and that becomes our upthrust. Therefore, the upthrust is 0.25 newtons. That is the upward force acting on the 0.5 newtons, so that a net force, or rather an apparent force of 0.25 is noted. So that is the upthrust and how to identify it. We have a part 2 which says calculate the density of the solid. Calculate the density of the solid. Now the solid we are dealing with is the 50 gram solid. The 50 gram solid. There is something we've noted about upthrust in the statement of Archimedes' principle. When a body is fully or partially immersed in a fluid, it experiences an upthrust equal to the weight of the fluid displaced. So weight of fluid displaced equals to 0.25 newtons. Which means we can get mass of fluid displaced. Mass of the fluid that will get displaced is going to be, from weight, for us to get mass, we need to multiply by g. So it becomes 2.5 kilograms, which is equivalent to 2500 grams. 2500 grams. So this is the mass of the fluid that gets displaced. And if this is the mass of the fluid that gets displaced, we can get volume of fluid. Of course, that was displaced now. Volume of fluid that got displaced. It should be noted that because density is mass out of volume, then volume will be equal to mass out of density. Mass out of density. So a mass of 2500 and a density of 0.8. A density of 0.8, because this is 800 and these are kilograms per meter cubed. Therefore, we use 0.8 because these are grams. So these are grams per cubic centimeter. 2500 out of 0.8. This gives us 3125 cubic centimeters. So the volume of the fluid that got displaced is 3125 cubic centimeters. And now, for this solid now, if it displaced a liquid or a fluid of this volume, then that also becomes its own volume because it was fully submerged. So we also conclude that volume of solid also becomes 3125 cubic centimeters. Now for the solid, we are having its volume and we also have its real mass of 50 grams. That means we can get density by mass out of volume, a mass of 50 divided by a volume of 3125, sorry. This will give us 50 out of 31. This gives us 0.016. These are grams per cubic centimeter. Otherwise, we can multiply by 1,000 and this will give us 16 kilograms per meter cubed. 16 kilograms per meter cubed. So that becomes the density of such a block. We can continue now. In the last bit, we are told that a hydrometer of length 8 centimeters, when dipped in water, a length of 5 centimeters is left above the water surface. Calculate the height not submerged when dipped in a liquid of density 800 kilograms per meter cubed, given that the density of water is 1,000 kilograms per meter cubed. When we are having this hydrometer such that when dipped in water, we will have 5 centimeters hanging. It means 3 centimeters have been dipped and water is having a density of 1,000. So if a density of 1,000, in a density of 1,000, 3 centimeters will get submerged. What about in a density of 800 kilograms per meter cubed? We expect a bigger length to be submerged. Therefore, we will take 3 and we increase 3 in this ratio. So we're going to increase the length of 3 centimeters by the ratio 1,000 is to 800. So we multiply by 1,000 and we divide by 800. We cannot just cross multiply to have 3 multiplied by 800 of 1,000 because that would give us a smaller length. But when we get to density and the stories of sinking, then it means in the smaller density, a bigger length will get submerged. A bigger length will get submerged. So we increase this one in the ratio. So this means when we take 3 by 1,000 and we divide by 800, this will give us 3.75 centimeters. This is the length that will get submerged. That means the length which is going to be floating. Calculate the length not submerged. So the length that will not be submerged will be 8 minus 3.75, and this will give us 4.25 centimeters. So this becomes the length above the liquid surface. Remember to follow us on the line above here For more consultations and for online classes, reach out through 0704 153 366.